Question 3.10 to the power 7 electrons cross in 30 seconds through an area. What is the electric current? So here charge is, what is the total charge? So total charge is 3.10 to the power 7. This is the number of electrons. When this total number of electrons, when multiplied by 1.6 into 10 to the power minus 19, we get total charge. So this column, this is the total charge. So total charge is 4.8 into 10 to the power minus 2 coulomb. Now this amount of current flows in time t equal to 30 seconds. So electric current is defined as the rate of flow of charge. So charge divided by time. So charge is 4.8 into 10 to the power minus 2 coulomb. Time is 30 seconds. So this is 1.6 into 10 to the power minus 3 ampere. So this is the current flowing through the area. Now question number 2 yang see, the potential at a point is 20 volt. Calculate the amount of work done to bring a charge of 0.5 coulomb from infinity to this point. Here, so we consider a point. Here, at this point, the electric potential is 20 volt. So the work done in bringing a charge Q from infinity up to that point, say from a point, a very far point, say this infinity, dagi sigi point si for changu work done is given as 20 volt. So the work done in bringing the charge Q of, what is Q? Q is 0.5 coulomb. The work done is W is equal to charge into potential. So here charge is 0.5, potential is 20. So this is 10 joule. So 10 joule of work is done to bring a charge of 0.5 coulomb from infinity up to that point. Resistance R is connected across a battery of potential difference 20 volt. Here current, essentially current is 2.5 ampere. So 2.5 ampere current flows through a resistance R when connected across a battery of 20 volt. So according to Ohm's law, we get V is equal to Ri, where R is the resistance. Therefore, R is equal to V divided by I. So V is 20, I is 2.5. So this is ohms. So this is 8 ohms. How much charge flows through a wire carrying 2.5 ampere of current in 20 minutes? Here time is 20 minutes. 20 minutes second the satopukavanu. So 20 into 60 seconds. So current is 2.5 ampere. Now question is, what is the charge flowing through it? So now we know that current is charged by time. Therefore, Q is current into T. So current is 2.5 into 20 into 60. That is 3 into 10 to the power 3 coulomb. So question number 5. A nichrome wire has diameter 1 millimeter and resistivity of 1.0 into 10 power minus 4 ohm meter. Calculate the required length of this wire to make a resistance of 14 ohms. So here is a nichrome wire. You see, this is a nichrome wire. So the diameter of the wire is D equal to 1.0 millimeter. So this is 1.0 into 10 to the power minus 3 meter. Now suppose the length of the wire is M, and we can find out the area of cross section. Area of cross section is pi d square by 4, and the resistance of the wire is given as 14 ohms, and its resistivity is 1.0 into 10 to the power minus 4 ohm meter. This is resistivity of the wire. Now we know that resistance is rho L divided by A. Now we can calculate area of cross section. Area of cross section of the wire. Area of cross section A is pi d square by 4. So pi into d, 1.0 into 10 power minus 3 whole square divided by 4. So this is in meter square. So the question is, to get a resistance of 14 ohms, what will be the length of the wire? Now substitute R equal to 14 equal to rho Rho is given as 1.0 into 10 to the power minus 4 into L divided by A is pi into, so this square is 1.0 into 10 to the power minus 6 divided by 4. So this is 1.0 into 10 to the power minus 4 into L into 4 divided by pi is 22 by 7. So 7 will come in the numerator into 1.0 into 10 to the power minus 6. Therefore, L is equal to 14 into 22 into 1.0 into 10 to the power minus 6 divided by 1.0 into 10 to the power minus 4 into 4 into 7. So 7 to 14. 2 into 22 is 44 divided by 4 is 11 into 10 to the power minus 2 meter. This you can write as 11 centimeter. So question number 6. A copper wire of certain length has a resistance of 10 ohms. What will be its resistance after stretching to double its length? So here you have a copper wire. Area of the copper wire is A and length L. So a copper wire of length L and its area of cross section is A, then the resistance is rho L divided by A, and by question the resistance for this wire of length L having area of cross section A is 10 ohms. So it is given in the question. Now the wire is stretched to double its length. So L. Now new length L prime is L plus L, that is twice L, then becomes double. Then new area of cross section, you have to find out the new area of cross section. Nazagi where she stress tauta d, so that the length becomes double. When I stress with tauta d, magi area of cross section to pixel hakani. So L is new length, L prime is new length into new area of cross section. A prime is equal to initial length into initial area of cross section. Kaigina the volume length into area of cross section volume say volume will not change. Now length is 2L, area is A prime, so L into A, therefore new area of cross section is L into A divided by 2L. So this A by 2. Now area of cross section becomes half. Then new resistance. New resistance is R prime equal to rho L prime divided by A prime. Sige mata anja ko na khanggato si kaino resistivity, or we call specific resistance. Rho does not change. Asagi rho is constant for the particular material. It does not depend on its geometrical dimensions. As a length, area of cross section change the my resistivity hongoi. Aduna rho is constant on the line. Say rho is constant on the line. So rho L prime is 2L divided by A by 2. So city 4 into rho L by A. So this is 4 into rho L by A. The equation 1 dagi akona khange. This is 10 ohms. So it is 40 ohms. Asagi length of the wire to double times stress to my resistance to 40 ohms. So here two resistors of resistances 10 ohms and 20 ohms are connected in parallel. A battery supplies a current of 6 ampere to the combination shown in the figure 8.17. Calculate the current in its resistor. Now, so this is 10 ohms. ohms. See battery in the समय सदा हम इसी सीधा बैटरी जितगी सेल P supply to about current 6 ampere नहीं. Then सीधा I1 I2 क्या नो I1 क्या नो तो कौन ohms नो दगी कौन सिकी circuit say V is the potential difference applied. Now current से चले सिकी junction से current 6 ampere चले सीधा I1 से निकले सीधा I2 से निकले then सीधा I1 plus I2 equal to 6 ampere na throw kar. Now we have to find out what is the potential difference. Now see ki resistance ani hai parallel combination of 10 ohms and 20 ohms. Here koi आगे equivalent resistance बताओ 6 ampere. There suppose I hierarchy. So R is the equivalent resistance. So V. Now 1 by R equal to 1 by 10 plus 1 by 20. So LCM is 20. So 2 plus 1. Therefore R is equal to 20 divided by 3 ohms. So 시계 resistance 20 by 3 ohms. 어떨 시계 20 ohms resistance is 6 ampere current cheli. So now V equal to Ri equal to R is 20 by 3 into current is 6. So 40 ohms, 40 volt. So here the potential difference is 40 volt. So this is 40 volt. Then circuit circuit 1 to the boxy. So this is equivalent circuit. Now see the R of 10 ohms. See the change of current. Say change the current to say I1. Say I1. I1, what is I1? I1 is current flowing through 10 ohms resistor. So I1 is V divided by 10 ohms, that is V is 40 by 10, so this is 4 ampere. So essentially current say 4 ampere when I1 is 4 ampere. Now what is I2? I2 is current flowing through 20 ohm resistor. So I2 is V divided by 20. So V is 40 by 20. So this is 2 ampere. So current flowing through this 20 ohms resistor is 2 ampere. So I1 plus I2 is 6 ampere. 6 ampere is divided into 4 ampere through 10 ohms resistor and 2 ohms in the 20 ohms.